In this video, we'll introduce you to NumPy arrays in Python. NumPy is short for Numerical Python, and it is a Python library that we use for numerical computations. It is essential for most machine learning workflows, so you'll likely spend quite a lot of time in the next 2.5 weeks and beyond working with NumPy. Now, there are a lot of reasons to use it. 3 of the most important are: 1, its efficiency, so it's known for allowing really fast operations on matrices. It provides support for a variety of different functions: mathematical, logical, and statistical, and it is the foundation for many scientific computing libraries that you'll be working with, like SciPy, Pandas, and TensorFlow. Now, because NumPy is a library and it's not built into Python, every time you use it, you need to import it. So every new Jupyter notebook that you create or Python script that you create, you'll need to add this line of code right at the beginning of that document. You just write import NumPy as NP, and then anytime you want to use NumPy, you just use NP. Now, as a reminder, NumPy arrays are homogeneous, multi-dimensional arrays of numerical data. They can only have one type of data, and it has to be a numerical type of data. They can be one-dimensional, two-dimensional, or multi-dimensional. And there are several ways that you can create a NumPy array depending on what you're going to use it for. First, you can create an array from a list using the np.array command, and then in the parentheses, either write the name of a list that you've previously defined or just put the list right there, as I have in this example. You can also create an array from a range using the np.arrange command. And then within those parentheses, you'll see there are 3 values. You have your start and stop values, very similar to when we were discussing indexing in lists. And you have a step value, which determines the interval between each element of your array that you're creating. So again, the start value is inclusive, the stop value is exclusive. And in this case, we're looking at every other number starting at 0 all the way up to 10, but not including 10. And that's what we've gotten when we print out this array that we've created. You can also create an array of zeros, just full of zeros, or full of ones using the np.zeros or np.ones function. And what you do is you specify the shape of the array that you want to create. So the first value is going to be the shape of the outermost dimension. And then from there, you go further and further inward into your array, depending on the number of dimensions you have. So in both of these cases, we're creating 2-dimensional arrays. And you can think about arrays as lists of lists in this case. So the outermost dimension would be the number of lists that you have, and then the innermost dimension for a 2-dimensional array would be the number of elements within each of those lists. So for NP0s, we're creating 3 lists with 2 elements per list, and for NP1s, we're creating 2 lists with 3 elements per list. You can also use a variety of functions and methods in NumPy. These are just a few of them. There's many more. I encourage you to go out and investigate what else you have available to you using NumPy. You can do element-wise operations. So as an example, you might add 2 arrays together. And by doing that, what you're actually having Python do is add each of the elements in array 1 to the elements in array 2. And this is an example of what the outcome would be of doing that. You can also multiply each of the elements in your array by a specified value. You can also divide them, etc. This is an example where you are multiplying each element in array 1 by 2. You can also aggregate and describe your data. So you can determine the mean, the sum, the standard deviation, the minimum and the maximum values, and many more. These are just some essential and very common aggregation functions. Additionally, you might want to know the shape of your array. So in this example, we have a 1-dimensional array, and when we print out the shape, we simply get the length of that single dimension. We also might want to reshape our array. So we don't want it to be 1-dimensional, we want it to be 2-dimensional, and we use the same order that we used when we were creating an array of zeros or an array of ones. We start with the outermost dimension length and then move toward the innermost dimension. So if we want it to be 2-dimensional and we want to have 3 rows with 2 values per row, we would do it this way. You might want to figure out the type of data that's contained in your array. That might be very important for future machine learning uh, applications of your data. You do that simply by writing the name of your array.dtype, and it will tell you, here we've got integers in our array. And you can also index and slice an array just like you index and slice a list. So if you just want to pull one element based on its index, you can do it as I have given you an example of here, array 0. You can also do a slice. So similarly, you're going to use that start and stop for your slicing, and here you're going to get the elements at index 1 and index 2, but not index 3, of course. And you can use the start stop step to slice your array. So you might want to get every other value starting at index 1 all the way to index 5, and you can see what you get when you do that. Next, I'll have you challenge yourself. So you have a list of blood glucose readings from participants in your study. It's given to you in milligrams per deciliter, but you need to convert it to millimoles per liter. I've given you the formula for conversion. Please create a NumPy array with the glucose values that I've given you in a list here. Convert the values from milligrams per deciliter to millimoles per liter, and then finally calculate the mean and standard deviation of the sample. And here's our solution. So we've created an array from a list. We've done an operation on our array. And then finally, we have calculated the mean and standard deviation of our array. And you'll notice throughout I've used this np.round function. It just allows you to specify the number of decimal places you want in the values that you're computing. Sometimes you'll get, of course, infinite numbers of decimals, and that can be quite annoying to deal with. So all that you need to use is np.round and put your function inside of there, and then follow that with a comma and the number of decimals that you want. So in each case here, I only wanted 1 decimal place. Thanks so much. See you in the next one.